The term Runlevel refers to a mode of operation in one of the computer operating systems that implement Unix System V-style initialization. Conventionally, 7 Runlevels exist, numbered from 0 to 6. Though up to 10, from 0 to 9, may be used. S is sometimes used as a synonym for one of the levels. Only one Runlevel is executed on bootup. Runlevels are not executed sequentially, that is either Runlevel 2 or 3 or 4 is executed, not 2 then 3 then 4. Runlevel defines the state of the machine after boot. Different Runlevels are typically assigned to single-user mode, multi-user mode without network services started, multi-user mode with network services started, system shutdown, system reboot. The exact setup of these configurations will vary from OS to OS, and from one Linux distribution to another. For example, Runlevel 4 might be multi-user, GUI, no server on one distribution, and nothing on another. Note the difference in the Red Hat and Slackware distributions charted in this article. However, Runlevels do commonly follow patterns described in this article. It is best to consult the particular distribution's available user guides. In standard practice, when a computer enters Runlevel 0, it halts, and when it enters Runlevel 6, it reboots. The intermediate Runlevels differ in terms of which drives are mounted, and which network services are started. Default Runlevels are typically 3, 4, or 5. Lower Runlevels are useful for maintenance or emergency repairs, since they usually don't offer any network services at all. The particular details of Runlevel configuration differ widely among operating systems, and also among system administrators. The Runlevel system replaced the traditional C script used in version 7 Unix. Standard Runlevels equals almost all systems use Runlevel 1 for this purpose. This mode is intended to provide a safe environment to perform system maintenance. Originally this Runlevel provided a single terminal interface running a root login shell. The increasing trend towards physical access to the computer during the boot process has led to changes in this area. Linux, the Linux operating system can make use of Runlevels through the programs of the sysinit project. After the Linux kernel has booted, the init program reads the init.ub file to determine the behavior for each Runlevel. Unless the user specifies another value as a kernel boot parameter, the system will attempt to enter the default Runlevel. Linux standard base specification: systems conforming to the Linux standard base need not provide the exact Runlevels given here or give them the meanings described here, and may map any level described here to a different level which provides the equivalent functionality. The additional behavior of Runlevel 1 varies greatly. All distributions provide at least one virtual terminal. Some distributions start a login shell as the superuser. Some require correctly entering the superuser's password. Others provide a login prompt, allowing access to any registered user. In some cases, Runlevels 2 and 3 function identically. Offering a multi-user mode with networking. Debian GNU Linux, Debian, as well as most of the distributions based on it, does not make any distinction between Runlevels 2 to 5, leaving that choice to the system administrator. Ubuntu 6.10 and later contain upstart as a replacement for the traditional init process, but they still use the traditional init scripts and upstart sysvrc compatibility tools to start most services and emulate Runlevels. Red Hat Linux and Fedora, Red Hat and most of his derivatives use Runlevels like this. The shconfig utility updates and queries Runlevel information for system services. SUSE Linux, SUSE uses a similar setup to Red Hat. System administrators can modify the services that run under a specific Runlevel by using EST system services, insiv or shconfig, as in the distributions based on Red Hat. Slackware Linux uses Runlevel 1 for maintenance, as on other Linux distributions. Runlevels 2, 3 and 5 identically configured for a console. And Runlevel 4 adds the X window system. Gen 2 Linux, Unix, System V releases 3 and 4, Solaris, starting from Solaris 10, SMF is used instead of SVR4 Runlevels. The latter are emulated to preserve compatibility with legacy startup scripts. HPUX, FreeBSD, OpenBSD and NetBSD. The BSD variants don't use the concept of runlevels, although on some versions init, 8, provides an emulation of some of the common runlevels. But invoking init with values below will produce results. For example, init 0 will halt the system. Also the init utility will do the above, if sent the user-defined signal to kill USR21. As init is always PID1. Runlevel signal action 0 SIG USR2 halt and turn the power off, 1 SIGTERM go to single user mode, 6 SIGINT reboot the machine, CSIG TSTP block further logins, QSIG up rescan the TTYS, 5, file. AIX does not follow the System VR4 runlevel specification, with runlevels from 0 to 9 available, as well as from A to C. 0 and 1 are reserved, 2 is the default normal multi-user mode and runlevels from 3 to 9 are free to be defined by the administrator. Runlevels from A to C allow the execution of processes in that run level without killing processes started in another. See also, init, upstart, kill5, systemed, external links, runlevel definition, by the Linux Information Project, what are runlevels? linuxquestions.org, references, Chapter 20. System Initialization 20.5. Runlevels. Linux Standard Base Course Specification 4.1. 2011. Retrieved April 21, 2011. Chapter 15. Commands and Utilities 15.2. Command Behavior. Linux Standard Base Course Specification 4.1. 2011. Retrieved April 21, 2011. Managing the Links. Debian Policy Manual. Retrieved September 18, 2014. Debian Linux Runlevels. Retrieved June 11, 2013. Ubuntu Runlevels. Retrieved June 11, 2013. Red Hat SysV Init Runlevels. Red Hat Enterprise Linux 3 Reference Guide. 2003. Retrieved May 22, 2013. ORI, ASGHAR. Red Hat Certified Technician and Engineer, Training Guide and Administrator's Reference. Laverne, Tennessee, Red Hat, Incorporated PA 319. ISBN A9781615844302. Retrieved February 27, 2014. The shcconfig command gives you the ability to display service start and stop settings, and set a service to start and stop at appropriate RC levels. Smith, Roderick WLPIC1, Linux Professional Institute Certification Study Guide. John Wiley & Sons. PA 239. ISBN A9781118059715. Retrieved February 27, 2014. The SysV startup scripts in the runlevel directories are symbolic links back to the original script. Numerous utility programs are available to help you manage these links, such as shcconfig, ntsysv, update rcd, and rc update. He first two of these tools. A. Re-supported on most distributions. Brown, Chris. SUSE Linux. O'Reilly Media, Incorporated PA 231. ISBN A9780596553623. Retrieved October 7, 2013. The unimaginatively named utility shcconfig can be used to manipulate and interrogate the slinks and clinks from the command line. Slackware Linux Runlevels. Retrieved June 11, 2013. Gentoo Linux Runlevels. Retrieved June 11, 2013. Solaris boot process. Amrita Sarjikan. Retrieved August 19, 2009.